Hey guys, in this video we're going to be looking at slopes of parallel and perpendicular lines and comparing them and finding them and just looking at and seeing how they work. So first we're going to start off with parallel lines. When you're looking at the slope for parallel lines, they're going to have exactly the same value. So if they tell you that the equation of one line has a slope of 2, and you're looking at a parallel line to that, it's going to have the same exact slope of 2. So if you look at that in a picture, the lines are going to be looking like that. They have the same exact slope. Today we're looking at the numbers and how the numbers compare. So an example of how they could show you numbers is they could say line D has a slope of -9/5. So slope for line D is going to be -9/5. They tell us that E is parallel to line D. So shorthand for parallel is two little lines that go together like that. And you can put that up there with your definition. So that's just shorthand to say parallel. So E is going to be parallel to D. And it wants to know, what is the slope for line E? Well, if we go back to our definition, they want parallel. Parallel means same. So we want a value that has the same exact value. So slope for line D is -9/5. Slope for line E has to be exactly the same, so it's going to be -9/5. Looking at the next one, they could give you the equation of a line and then ask you what the slope of another line parallel to that would be. So then you only want to focus on your slope. So this is in slope-intercept form, which is y is equal to mx plus b. So the only thing I need out of here is the slope, which is represented by an m. So the slope for line V is going to be equal to -3/5. And they tell us that W is parallel to V, and they want to know what is the slope of W. It's got to be the same. So -3/5 is going to be our slope for line W. Okay. Looking at the next example, it says line V passes through those points and line W is parallel to line V. What is the slope of W? Well, when we're talking parallel, we've got to compare the slope of W to the slope of V, but they don't tell us the slope of V. What they do is they give us 2 points. And from those 2 points, we're going to have to find the slope. So if you remember, our equation or our formula to find slope, m is equal to y2 minus y1 over x2 minus x1. So this is an x value, this is a y value, that's an x value, that's a y value. But to tell them apart, I'm going to call this one x1, y1 because that's in the first point, and this one's x2, y2 because those are in the second point. So then I'm going to do, the slope is going to be equal to y2, which is 3, minus y1, which is 10, divided by x2, which is 8, minus x1, which is 4. I'm going to bring it up there. Slope is going to be equal to 3 minus 10 is -7 over 8 minus 4 is going to be 4. So our slope for line V is going to be -7/4. And they tell us that W is parallel to V, and then what is the slope of W? So they want to know parallel. Parallel means same. So what is the same for slope of line V? Well, -7/4. So that'll give us our slope of line W. Okay. Looking at the next type, we're going to talk about the definition uses some words that we don't use a whole bunch, at least in terms of math. So one of the words is going to be opposite, and this is terms of the negative or the sign. And you're going to switch the sign. So if you do the opposite of a positive, it's going to become a negative. If we do the opposite of a negative, it's going to become positive. Okay? The other one we're going to be looking at, word we're going to look at and talk about is reciprocal. Reciprocal is just a math word for you flip a fraction. So if you have a fraction that is a over b, you're going to have b over a. So you flip it. You take what's on the bottom, put it on the top, and take what's on the top and put it on the bottom. Okay? So that leads us to the slopes of perpendicular lines. Slopes of perpendicular lines are opposite. So remember we switched the sign. Reciprocals. So switch and then flip. But whenever I talk about them, and a lot of times whenever you hear any math person talk about them, and especially on tests and stuff, they're going to say opposite reciprocals. You're not going to see the words switch and flip. So it's going to be really good for you to get in the habit of using those words. So looking at the first example that we have, they tell us that line R has a slope of -3/2. They tell us that line S is perpendicular to line R. And this little symbol right here is a symbol for perpendicular. And they want to know what is the slope for line S. So perpendicular, when we're talking about slope, it's going to be opposite reciprocals. So if we do the opposite, and I focus on these words one at a time. I don't try to do everything all at once. So first thing, opposite, well, opposite of a negative is going to be, it's going to be a positive. Reciprocal, I've got 3/2, and if I flip it or reciprocate it, if you're looking for the math word, is 2/3. So double check. Did I do the opposite? Yep, started with negative, now it's positive. Reciprocal, 3/2 to 2/3. So that is the slope of line S that is perpendicular to line R. Looking at the next example, they give us an equation of a line and ask what is the slope that is perpendicular to it. So they give us a lot of information. They actually give us slope-intercept form. Y is equal to mx plus b. So focus on just the slope. So the slope for line P is going to be 8/5. They tell us that Q is perpendicular to P, and they want to know the slope for Q. So perpendicular, opposite reciprocal. Okay, so opposite, this one is positive, so I'm going to make this one be negative. Reciprocal, 5/8. And that is the slope that is perpendicular to 8/5. Okay. Looking at the next example, they give us a line that passes through 2 points. Then they tell us that we're looking at another line that is perpendicular to this one, and they want to know what is the slope of that new one. Well, those are points. Those are not slope. So we need to make them be a slope. We're using that slope formula. The way you find slope between 2 points, you do y2 minus y1 over x2 minus x1. Well, I've got a whole bunch of stuff to keep track of, so let's label it. Well, this is an x-coordinate, that's a y-coordinate. This is an x-coordinate, that's a y-coordinate. Well, how do we tell which x is which? I'll say this is my number 1 point, so that will be my x1, y1, and this will be my number 2 point, and that will be my x2, y2. So then we're doing, our slope is going to be equal to y2, which is 10, minus y1, which is 17, over x2, which is 10, minus x1, which is 4. So that's going to leave me with slope is going to be equal to 10 minus 17 is -7 over 10 minus 4 is 6. And this is our slope for line C. So they want to know, they tell us line D is perpendicular to C. And then what is the slope of D? Well, perpendicular means opposite reciprocal. So opposite of a negative is going to be a positive. Reciprocal of 7/6 is going to be 6/7. Okay, so that's going to be my slope for line D. Okay, you could also have problems where they start mixing stuff together. And looking at this example, they tell us that we have an equation of line T, is y is equal to negative 5/6x plus 1/7. They tell us the equation of line U is y is equal to 5/6x plus 5/2. And they want to know, are line T and line U parallel or perpendicular? Well, in order to be able to tell parallel or perpendicular, we've got to compare the slopes. So that means I have to know the slope for line T, and I have to know the slope for line U. And they gave us slope-intercept form. So y is equal to mx plus b. Right here is my slope for this one. So my slope for line T is going to be negative 5/6. And then here we're looking y is equal to mx plus b. So there is our slope for line U. So they want to know, is it parallel or perpendicular? So remember, parallel means the same, and it means exactly the same. This one's negative, this one's positive. That's not exactly the same. I know they have the same numbers, but they don't have the same value, so they're not going to be parallel. So then we're looking at perpendicular. Perpendicular means opposite, reciprocal. So if we look at that, this one's negative and this one's positive. So it is an opposite, but it's not a reciprocal. If I were going to do the opposite reciprocal for this one, it would be positive 6/5, and it's not. So it's not perpendicular, so this is actually a neither. And that's okay, it happens sometimes. Sometimes it's neither of them. And the last example that I've got for you, line M passes through those 2 points. Line N passes through those 2 points. And then from there, they want to know, are they parallel or perpendicular? And again, to compare parallel and perpendicular, when all you're looking at is numbers, you've got to compare the slope. And with these, they don't give you the slope. So we've got to do that slope formula to find slope. So slope is equal to y2 minus y1 over x2 minus x1. So x1, y1, x2, y2. So your slope is going to be equal to 17 minus 9 over 3 minus 8. So slope is going to be equal to 17 minus 9 is 8 over 3 minus 8 is a negative 5. And that's simplified. And again, I'm okay with improper fractions, so I'm going to leave it just like that. So that gives our slope for line M. Now we need our slope for line N. So we're doing our slope formula all over again. So slope for line N is going to be equal to y2 minus y1 over x2 minus x1. So this is a whole new set of points. So I'm just going to ignore this and then label these all over. x1, y1, x2, y2, and then my y2 value is going to be 8 minus y1, 4, over x2 is 8 minus 5. So our slope for N is going to be equal to 8 minus 4 is 4 over 8 minus 5 is 3. So are those parallel or perpendicular? No, they're not even close. Yeah, they're opposites, but those numbers aren't even close, so this is also a neither. Alrighty guys, there you go. There's your review, or sorry, not a review, but there's you how to do parallel perpendicular slopes.